What up, Jesse Warden? Okay, this is going to be big. We're going to cover functions. Functions are, at their very essence, simple. They are just a named block of code to run a bunch of code. So if you want to run all this code again and again and again, you give it a name and call it. That's it. That's really what functions are. They are used in just about every programming language in some form or fashion. They're called functions, operations, subroutines, whatever. But bottom line is that functions actually have a lot of subtle parts that together form very powerful functionality that's flexible and cool and awesome. So it's going to take a few videos to cover it all. What we're going to cover in this one is not the hardcore advanced stuff. We're just going to cover the named ones, the anonymous ones. We're going to cover the function parameters, dealing with the arguments array. It's a magic thing that it has. We can do REST-based functions, dealing with local variables and some scope basics. We'll cover that in greater detail in future videos. Dealing with return values and how that builds upon that previous functionality. Functions that call functions, right? That's kind of what most programs do. So let's start with just named functions, okay? Named functions are functions that are defined at compile time. So what that means is when your JavaScript's compiled and run internally by the browser, it's not really compiled, but some browsers do nowadays. You can give it a name, and it all starts with function, keyword function. You have to have a space after it to give it a name. We're going to call ours test. And you have the curly brace open, the in curly brace. That's it. You now have a function. So whatever code you put in here, you notice I use an indent. Some people like to use spaces. I like to use tabs. That's also a religious word. Let me show you the other religious word. It's even bigger. Some people cuddle them, right? They either put it here or here. They cuddle it, cuddle it, because the brackets, the curly braces are there. Other people like me do this. I like to have it aligned so I know where it starts and ends. So that way if I nest things, I know where they are. That's my preference. Whatever you do, make it consistent. If you're working with somebody whose style is different than yours, I'm sorry to hear that. Those are fun projects. So we're going to call console log hello world. Yo, what's up, world? What's up, man? How you doing? Man, you living on me. I sure am. You have to bear with me this morning. I knew it would take a lot of coffee to go the cover functions. It's a big one. All right, so we have a function, but you notice it doesn't do anything, right? Just because you defined it, said function name, and put some code in there, doesn't mean anything. We have to invoke our functions, or call them, or execute them, whatever you want to call it, right? So we're going to do tests. The way we do it is we call the function's name with left parenthesis, right parenthesis, right? Just like a definition, but we actually have to put these parentheses. So if you do this, nothing happens. But if you put the parentheses, it now invokes it. Right? So hello world. So we've actually executed this function to run. So if you want to actually see it happen, we're going to put a breakpoint on line 12 here so you can see. Watch her run. Let's put it on line 12, okay? We're going to refresh. So our test function is starting. Our code's defined. Notice it doesn't run technically the function. It just waits to go down there. Then it goes in the function, runs the block of code, and then hits the last bracket and says, and I'm done. That's it, right? Shows the console, good to go. So that is the basics of named functions. You name them, you call them. We can make another one. Call it add simple. We'll say let's say a equals 1 plus 1. All right, so we're gonna call add simple, and then we're gonna trace out the A. You see hello world, and A is 2 because A is 1 plus 1, right? So we executed that. It defined A on the global scope, and we can see it. So that's another way. Notice we now have 2 functions, and we've called them. You can call them in any order once they're defined. Doesn't matter. You can also do something magical with name functions, and that is execute them before they're defined. Because your program first is scanned and looked over, and all the things are defined, then it runs your program, right? So that's what's cool about name functions, that you can do this thing called forward reference. It means test, I don't know any test, dude, he's down there. Oh, okay, I'll go look. That's how name functions work. They're defined, they're ready to go. Once your code is actually executed line by line, then you're good to go, okay? So refresh, you can see it still works just fine. So that is named functions. So what is this anonymous function? Anonymous function doesn't have a name. So if you know what anonymous means, people post anonymously online. That means they don't have a name, or they choose not to go under the moniker, which is ironic. And I know that ironic has all kinds of hardcore definitions nowadays, so I'm just going to abuse it. And I think it's ironic that anonymous is a name, technically. You have to have a name to post online. You got to put something in that field, right? So it's anonymous. So let's show you an anonymous function. Anonymous is, you give, let's just say, a variable, let's call it cow. Notice I do function with no name. I just do the parentheses right there. Then I do my bracket, okay? And then I go console.log. So, I'm anon. Again, nothing happens when you define a function. The difference between this function is, you'll notice if we set a breakpoint on this guy, okay, and then we call it, so it says sup anon, right? You can call it the same way. But watch what happens when we put a breakpoint here. Notice it's not defined until we actually run the code, defines it as cow, that variable, then it executes, right? It goes inside the function and runs. Now it seems subtle, but watch this. If we go back to what we had before, where we just change it and say, we don't need a cow, right? Go to our sources, put our breakpoint up there. So you can't even put a breakpoint on this function definition. You put it inside. See, the function definition is the name functions are defined before the program even executes. So that's a subtle difference. Why? There's a lot of reasons why it's a big deal, but for now, watch this. The only thing you can't do for now, basic things, you can't forward reference. Okay. So this will work just fine. We can take our breakpoints out. So you can see it works just fine. As soon as we change it to anonymous, she ain't gonna work. She ain't gonna blow up good. Oh, look at that. It broke on cow. Ba-boom. Right? It exploded. So you can't do that. So that's one subtle thing about anonymous functions. Cool things, though, is they're a variable, right? So functions are technically a data type, and a very powerful and awesome data type as well. Functions are actually more powerful than objects in JavaScript, even though most of your time you spent writing objects are inside of functions. Really, because functions are both a data type and they have all kinds of properties like objects, but they can do things. Objects themselves just hold data. They don't really do anything. They rely on functions within them to do things. You got it? All right. So that's named functions. That's anonymous functions. Let's talk about the parameters. Parameters, okay? So functions are supposed to be dumb. They're supposed to be, I'm supposed to do this one thing and only this thing, and I have a name, right? So if we have a name for something such as add numbers, let's say add 2 numbers, right? It's kind of obvious what he does, right? And this is kind of something that you should get into, is naming functions that are obvious. So don't go add 2 nums. Like that kind of stuff is old and gone. There are JavaScript optimizers, yada yada. Premature optimization is the root of all evil. You should write readable code. It is possible to somewhat easily optimize readable code. It's very hard to optimize unreadable code. So you should strive to write code that's English, right? Better than my English. You should be able to read it and understand what it does, okay? So that is add 2 numbers. We're going to go back to the add 2 numbers, okay? So it's cool, but what 2 numbers? How does it know what 2 numbers to add? Well, you could go var A equals 1, var B equals 2, and then say var A or C. Let's just say C. Var C, I don't know what it is. I'm just going to say var C. It's up there ready to go. See, you don't have to do var C. Remember, JavaScript is dynamic. You don't have to predefine variables if you don't want to, because everything's a variant and dynamic. Let's log out what C is after we call add 2 numbers. So it's 3. Duh, right? But that's not very flexible. What if we want to add any 2 numbers on the planet? Well, you can do something dynamically called adding parameters. So let's show that. Let's get rid of these crazy variables. And we're going to say first number, second number. Now notice they're orange. That is my IDE, my colors theme. Yours may be different. You may not have colors, right? You may see the world in black and white, and that's fine as well. It is what? 1 out of 3 males is colorblind. The point here is that these parameters are different. They are dynamic variables. They will be whatever we pass into the function, right? Which is great. They can be whatever we want them to be. Okay, so we're going to say console.log first number plus second number. So we can have a lot of fun with this. Let's do add two numbers, 1 plus 1, 2 obviously. Let's call it again with two completely different parameters. Now again, parameters are something in these parentheses, and the way you designate 1, 2, and 3 is commas, right? Doesn't matter what it is, a number, a string, an array, a cow, doesn't matter. It's got to be a parameter via a comma. You can put a space or not, doesn't matter. I like to put spaces, and I like to keep them nice and tight. Some people do this, that's cool too. Whatever makes you feel comfortable in your world. Ugh, coffee makes me feel comfortable in my world. 2 plus 1 and 10 something or other to blah. Ready? Go. So, as you can see, same function. Takes any parameters, two parameters you want, and we'll add them for you and print them to the screen, right? Very flexible, reusable block of code there we have, right? We have the algorithm of plus. Now you can see that you could write some more complicated algorithms adding two numbers, right? The point here is that that function, whatever you name it, whatever you put the parameters are, dynamic, you can reuse that function for a variety of purposes. And this is where the core concept of building programs or reusable logic comes from. It's all housed in these little functions, constructs, okay? So I don't even know what that is, but it's a big number, blah, 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 blah. But you can see the point, right? Those are parameters. You can put as many parameters as you want, but it's only going to use them via named parameters. And these are called named parameters because we gave it a name. We can call it whatever we want. We can call it cheese and cow, and then add cheese and cow. Refresh, same thing, right? But that's not very helpful. We need to know what is that. First number, second number, right? It helps us identify what those parameters are. So that's why we call them named parameters. We get them names that make sense. And again, this is, you know, one of the two main hard things in programming. That's dealing with cache invalidation and naming things, right? So once you start dealing with functions and numbers, it's okay to start coding, then stop, and then think. Because that's, sometimes it's hard to make up names for these things, okay? And to the commenter on my previous YouTube video, in the world, one function, the icon. Alright, so that's two numbers. So that is function parameters. Now, what if you wanted to have an arbitrary number of functions, or parameters, sorry, like this? Why can't we just put an infinite number of numbers to add, right? Well, you can. It's called the arguments. So let's print it out, and you can see this magic array. It's an array that all functions get. Each one gets its own array, right? Its own reference, its own unique copy. And we'll show you what the arguments are passed. So the first one gets an array of 1, 1, 1, 1, 1, 1. The second, as you can see, is 2 and 1. So the parameters you pass in are stored in this arguments array. And this arguments array is unique per function. So each function will get its own arguments. If you pass in none, it won't be null. It'll just be an empty array. That's an important point, right? Dealing with default nulls in JavaScript in any programming language is pretty rough. At least for here, they give the conscious effort to say, look, you might not use it, but we'll just default it to an array anyway, so you don't have to worry about null pointer, etc. Thank you, ECMAScript. Okay. By the way, what is ECMAScript? ECMAScript is the standard on which JavaScript is based, and a variety of other JavaScript-like languages, right? They try to follow ECMAScript standards, even if they're not JavaScript. So when I say ECMAScript, I'm referring to JavaScript. When I say ECMAScript, it is the salvation of JavaScript. Even though people abuse it, we'll fight our way out. So that is the way to get at those dynamic parameters. So how do we use them? Well, let's do something called our next thing, which is add them together. So we will take let's just make a variable called amount. We'll set it to 0 by default. We'll then do a for loop to loop through the array, right? We cover this in advanced arrays. If you don't know what I'm talking about, go look at my other video for that. We'll make a temporary iterator, I. Shouldn't use I, you should use iterator. Don't use single letter variable names like I do. Bad practice. I'm doing it because I'm lazy. So say I is length of arguments. I plus plus. Every loop, increment I by 1. So I can use that as the index for the array and go 1 and 1 on 1. Right? If it's a decimal, you're going to freak out. Nothing's going to work. Stay away from the floats, bro. You ain't drowning. No need for floaties. You're a good swimmer. All right, amount equals arguments. And we're going to use a shorthand here, but I'll make it simple. Amount equals amount plus arguments I. So the first will be 1. The second will be 1. The third will be 1. So it's going to keep adding that to the amount and keep adding it again, again, and again. Right? Since we do amount equals amount plus, you take what you already have, add the new number. Take what you already have, add that to that. Right? So you keep getting bigger and bigger and bigger. This will give us the sum. Right? The sum amount of adding numbers together. Standard math stuff here. Okay? Then we will print it out and say, hey, when the loop is done, what value did you get? Also, what I just did is a very common error in JavaScript. People do it all the time. This guy included colon. JavaScript gets mad when you do that. It thinks it's a switch and goes, brr. Right? I'll show you what happens. This happens all the time. Unexpected token, brr. What that error really should say is, I think you meant a semicolon. Can you go look in this line and see if you accidentally put a colon? Yes, I did. Thank you. Helpful error message. My bad. Glad you got my back, bro. So, semicolon. Right? Happens all the time. So that's what that error means. Just happens all the time. I hate when people give tutorials and they don't. Yeah, but I got an error. What does it mean? Why doesn't your tutorial cover the errors? Well, mine just did. All right, so we'll refresh it. And again, we have a function called add two numbers. We've given it the ability to take an amount variable and constantly add all the values of arguments we had, one in turn, right? We loop through everything from start to finish. And we constantly keep adding it and adding it to this amount variable and say, all right, when we're done, what is the sum number? Now, each time we start, we reset amount to 0. So we start from 0, okay? So we could theoretically support negative numbers as well. Why does everything default to 0, Jesse? Like, that's a negative outlook. It is not a negative outlook. It's just math. It's not negative. So, as you can see, the first one, I have 6 ones. The value is 6. The second one, I have 2 and 1. Its value is 3. This is the same number as before. 0 is the last, right? That's the default value because we don't have any arguments, so it doesn't run the loop. So just 0, right? So that's the cool thing about arguments is doing a variety or, 0 or many different arguments. Put as many as you want, right? The challenge here is there's no named arguments. Well, what happens if you put named arguments? You can do that. First cow, second moo. Nothing changes. You don't have to do them, but that's another way to access via a name the first item in the array and the second item. But no one does that. You could do that if you had like 2 parameters in the front of the function that you had to pass. The third one was optional. You could do that if you wanted to, and you could access it via arguments. So for example, let's show you how to do that. Let's say you had 2 numbers, but the third was, I want to have an optional. So we'll say console.log, first cow, copy pasta coding, second moo, and then arguments 3. 0 base, so 2 is 3, right? Third position in the array. So we'll say add 2 numbers. 1, let's do 4 and then 8. And as you can see, that is the 1, that is the 4, and this is the 8. So even though there is no way or no named parameter to access it, we can still use the arguments to do that. So you can support both if you wanted to. There's some functions that actually have valid functions to do that. I'm being a little mean here. Okay, so that is the concept of arguments and name parameters. You've got that stuff. You've got REST-based functions, which you can supply 0 to many different arguments, a dynamic amount, doesn't matter how many, okay? So, you notice how I did amount earlier, and I said equals to 0? Well, here's the problem. What if somebody else wants to borrow the amount? And this is where we get into scope. So let's cover scope right now, the basics of scope. Everything in function, because that's what JavaScript is comprised of. Made, assembled by, right? Speaking of assembled, anybody see that Sentinel video? Sentinel heads? They look smaller in the video. Remember like the people were walking down the beach and Sentinel's like, I'm watching you, and people are like, yeah, I'm with my kids. I always thought the Sentinel was like really big in the cartoons in the 90s. Whatever. I'm sure it'll be cool. Alright, so everything's in JavaScript is composed of scope and functions. Functions have their own scope. JavaScript in general has its scope. So let's talk about the main scope that we've already covered, and that is stuff here, right? What does that mean? So we'll call it amount to make it really obnoxious and easy to find. Okay, so we're going to run this. So how do you see scope? Scope is where all your variables are stored. Where are they? You can access them by name, but you have to access them by name in a certain scope. Scope is where are things stored. So when people say scope, you're like, what does scope mean? Scope means where are things stored. Okay. And if you know where they're stored, you can access them by name, similar to an address, right? But it uses names or strings. So if we go to the sources and we set a breakpoint, at any point in time, we can pretty easily see the scope, okay? There's this thing called window. So I'm going to show you global. Global is called window. It's synonymous with global. All browsers have window. Window is basically an object that represents the window, the browser window we're running in, right? The browser window can have a variety of variables created within it. By default, browsers already have a ton of globals. They have infinity for math. They have arrays, the actual class array that you instantiate. They have deal with audio buffers, all kinds of DOM stuff, HTML things that they use, yada, 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 yada. All this stuff is globals that are already there. So you can't really make variable names of those. You could, but they won't really work right because they're hiding. You can't have two variables of the same name. They're going to be the same thing, right? We all access by unique names. Amount, there's only ever one variable called amount in the window scope for every scope. So if you look, all your stuff that you make by default goes here. So we could find our dude right there. See amount 0? He's nested in that variety of globals. Now, this namespace, as they call it, or global area called window, we can make our own. So you can say, look, I don't want to go in there looking for variables, right? Because if you did that, you'd have to go to console. Let's hit play here and I'll show you what I'm talking about. So you can actually print out window and see that he's an object like everyone else. I didn't define one. He's already there, right? I didn't have to define a window variable. It comes preloaded, ready to go. So JavaScript is not a blank slate. JavaScript running in the browser already has all these things. And you can open window and see all the variety of things in there, okay? We can also print out our amount variable, right? And it's the same thing as our variable if we just go amount. So when you type in the console like this, it's defaulting to window. It assumes you mean window dot whatever you type. Make sense? So let's make our own namespace, our own object to store things. We'll call it holder object. Let's save. We'll reload. Holder, as you can see, is the same thing as window holder. Same exact thing. To prove that, Jesse, okay, holder equals window to holder. I'm still not convinced. Okay, holder equals. I'm still not convinced. Well, you know what? Good for you. So that is a namespace. We're going to add some things to. So let's do it. Call it amount. Holder dot some value we want to also store. True, man. Reload. So print out holder, print out window.holder, same thing. And you can see our variables are actually stored in there. So it's a lot easier to put things in your own little object so you don't have to go swimming around in global. Plus, you can put all kinds of class names in there and not have to worry about collisions, right? Where if you put them in global, other people's code might be there. You might have to be, you might both decide that G is a great variable name and suddenly he's got a G too. This happens all the time with older jQuery projects and everything else, right? jQuery is one of the libraries that uses a $sign for everything. So if somebody else uses a $sign, like, that ain't gonna work, bro. Whoever gets in first wins, right? So what does that mean, gets in first? Well, let's say, we say, no, I want to call the amount a boolean of, an amount is an array of 1s and 2s, okay? Well, who wins, right? Is it amount 0 or an array? Well, you can't have two variables with the same name. It assumes you mean that variable, right? So it's going to set it to the array. So when we go holder, you can see it's now an array, right? Same thing with global. It's going to override whoever runs afterward. Usually, there's some that you just can't redefine. Like you can't redefine window, right? For security purposes. So that is scope and where all your variables are stored. Functions are the exact same way because they're also data types and variables, right? You can store functions on Windows. So when you define things like cow, it does nothing, but at least it has a name, right? We say, what is cow? Well, it's a function cow. Is that the same thing as window cow? Yes, it's the function. It's defined on window, right? It's just a name function defined on window. Whatever, right? So that's why it prints out like this. Versus like this. Function all in one line that does nothing. What is cow? Written like that as an anonymous function. You can tell the printouts. Okay, great. So we know where our variables are stored. So why are you telling us about variables? Well, functions have this ultimate power called local variables. What that means is they create variables that temporarily live. They're created whenever you instantiate them inside them. And when the function is over, it's done executing, they die. Sometimes. So let's assume for now they do. I'll explain later why they don't die. So let's make a function, just like I had, add two numbers. And instead of amount, we're going to do var amount. Now you notice I've been doing vars up here. You don't have to do a var. You can say a equals 1, right? Or var b equals 2. Before I do this, I'll show you what that means. So we save it. A is 1, b is 2, right? Doesn't really matter when you define it in the global scope or the main anonymous script block. But in functions, var has special powers, okay? So let's show you what those special powers are. So we just define a variable called amount equals 0. We're going to call it. And then we're going to say console log amount. It's going to blow up. But I thought it was defined. No, it's not defined at all. What if we just print out the variable itself? Shouldn't it print out like 0 and not blow up? No, it's not defined. It doesn't exist. There is no amount. Why is that? Because when you define a var in front of a variable in a function, it's local and it dies at the end of it. Peace out. Nice knowing you, bro. Right? So that's a neat way. And why is that neat? Well, there's two reasons why it's neat. Number one, you can create temporary things to make your function easier to deal with and not pollute the global scope with a bunch of variables. You don't have to share. You can make your own. What does that mean? Okay, well, watch this. Amount. Remember I showed you it'll override amount? Let's call this cheese. Watch this madness. The beginning of the function, say amount is, and at the end of the function, amount is. So at the beginning of the function, it's undefined, right? Why isn't this guy seeing this guy? Because this is confusing it. It's saying, well, there is no amount defined yet. Well, how do I reference this guy? You have to use window. There you go, right? So this is how we use scope. We actually use name scope. Global is always implied when you do it, but once you start getting into locals, you have to start using the proper address. So you shouldn't really be using global variables in functions anyway, right? Because you want to make this flexible. Okay, what does that mean? Well, can I just go log down here and use it again? Yes, you can. Cool, so you can see it's still there. Didn't go anywhere, right? But this function gets confused because it says, well, he's got a var like down there called amount that I've already, ready for the name. So it must be undefined because it's not defined yet. That's correct. It's defined in this, but it doesn't have a value assigned. So this is the same thing as doing this right here, right? Now, what does that mean? Okay, well, let's back up to basics of variables again. If we say console.log amount, there is no amount defined on global by default in web browsers. So it will error out. It'll blow up, give us what's called a null pointer. In this case, a amount is not defined reference error, right? What if we do this? What's its value by default? We didn't set it to null, so it's undefined, right? So when you do that in a function, the browser is smart enough to know, okay, he's gonna do equal 0. That's the same thing as doing var amount up top. Then all your code runs, right? So it's kind of a pre-definition of it. So that's why you can't access it unless you do window. All right, so you know that you can do var amount. It's a temporary variable, and it'll die at the end of the function. So if we call it, amount won't exist at the end of it. Cool. So we can do our algorithm before. Notice I subtly did I as a var as well. That means that I can be used all throughout the program. Everyone and their mom can be lazy and use I as an iterator as long as it's done within a function, right? Don't do that. Very bad. You shouldn't use iterators, single letter iterators. It's bad practice, and for slackers like me. Did I say that out loud? And we'll do the shorthand because I'm lazy. Whoops, new line. Add two numbers, 1, 1, 1, 1, 1. Add two numbers, 2 and 5. Right? And the cool thing is, amount doesn't get affected at all. We could actually create another variable over here called amount and do things with it, and it would never affect this function, right? So that's what's great about local variables, is they keep that logic in those variables contained within the function. Nice and clean, don't negatively affect everybody else, and I can reuse the same name if it's prudent, not have to worry about it colliding with somebody else, right? If I wanted to do that, I could keep one on global and one inside the function. So that is basics of local variables and basics of scope. So again, you have any variable you create, whether it's a function or whatever else, it's going to be on global. Now there are ways of getting around this, but for now, anything that you write in this script block in your HTML page will be stored on global. Variables, functions, all of it, okay? You can get around this by making your own little objects, right, and storing things on them, or you can just use a lot of local variables and functions and only use variables up here for things you really want on Windows, okay? So that's how that works. That's why sometimes you'll have problems with functions having names being reserved, but most of them are not, okay? So that's locals. That's the basics of scope. You either have global or local variables. Only those two. So let's talk about return values. Notice how there's no way to get this amount out unless we add it. Like we actually have to print it to the screen. Well, what if I want it? What if I want to do something with that and add that to something else? Functions have this wonderful power of returning stuff. So I don't care what you do inside function. When you're done, just give me what you found out, right? Well, you can do something called return. Return does two things. Number one, it takes that value, whatever you put to the right of it, and gives it back to whoever invoked him, right? So if I invoke you, tell me what, when you're done, whatever you return, give it to me. I'll have a variable ready to catch it, all right? So that's what a return statement does. The second thing a return statement does is it halts execution of the function. So we can put all kinds of jazzy jazz Jeff at the bottom here, and it'll never run. Now watch this. Never see that console ever run. This runs. Prove it. Okay, I'll prove it. Refresh. It's going to call it twice. We're going to step line by line, right? Hops to the end and stops. Because that's what returns do. All right, so let's do something awesome with that return value. We got to define a variable to catch the value, okay? So we're going to define a variable to catch that value. First one's harder problem. So these two variables are going to catch the return value. Copy pasta. Get rid of a breakpoint. So there you go. You can see the return values are right there. The variables hold the return value, okay? So whatever this amount value is, they're going to return. Now we can screw it up. Call it 17. Magic numbers. And they'll both be 17, right? Obviously, that's not what we want. We want a function that does some cool algorithms like adding, a bunch of random numbers. Doesn't matter how many, there's an arbitrary amount. So we have this nice, useful function that's self-contained, doesn't pollute the global scope, right, with its variables. It names them whatever they want, amount and I. As long as they're var, they'll die at the end of the functions. They don't hurt anybody. And the only thing we care about is this name, which is defined on global scope, right? So, again, functions that are named have a function space, the name. You can put as many parameters as you want with names or not. If you don't put them, you can access them via the arguments array, which is magical. As long as you put a var in front of a variable inside of a function, it will be local and die at the end of the function. It won't be put on global, and you don't have to worry about name collision. The return statement does two things. It returns whatever value you put there to those who invoke it, and they can capture that in a variable, right? They can do whatever they want. It could be strings, it could be numbers, it could be a factory function that makes objects for you, whatever else, it's going to be stored there, right? and it stops execution. So if you have if blocks right in there, I'll show you an example of that. First value, second value. You can say if first value does not equal null, then return first value plus second value. Else, we're going to indent this. Now I have two return statements. So if it runs this, it'll stop after this, or it'll stop after this, right? So you can have multiple return values. You can also do this to be a jerk, and your function won't do anything. This is actually not a jerk thing. This is a move where you don't want this function to do stuff. It's not done, and it'll break your program. You can comment it out when you're done, but if you're still working on the function, you don't want it to affect things. You want to pause your work, right, on your desk. You can just say return. That way you won't run this code and won't blow up, right? Or you can just be other nice and comment it out if you have a nice tool that supports multi-line block commenting like Sublime does. Okay? So 2 and 7, right? It's always going to do this because it assumes that you set those values, right? I'll show you how you can do method detection later where you can say parameters. But here's something I wanted to point out. What if we do a parameter name that's the same as the local variable name? How does that work? Well, this is where you have to stop again and think, I really need to think about what I name my variables. This kind of stuff is awful. People think it's cool because, look, oh, okay, I've learned that this amount, if I do a var, overrides global. So it's going to use this variable, not the global one, unless I go window.amount. But if I put a parameter, that's a third level of hiding. So that means that this amount is different than this amount. That's different than this amount. So these two trace statements, amount is 1, because that's what I passed in the first function. But the second one's 0, because I redefined it. Now I redefined the amount, which is 0. But the result is different because we reset the arguments of 0 to the amount, which is 1. So it's not 1, 2, 3, 4, 5, 6 anymore. It's now 5 because it returns that amount, which is this particular amount, which is that. See why this is confusing? You shouldn't have to go down that route of logic and solve this. It's simply resolved by having nice descriptive names, nice consistent logic of what a function's supposed to do, okay? So you can do this in your local variables will also override parameter names. So local variables always win, but don't do that. Just name it something logical, okay? So that is REST-based local variables in Scope Basic with return values. So we now have functions. We have functions that can return things, okay? Note, you don't have to necessarily have a variable. Watch this. Any return value can be captured in functions, which have function parameters, right? So we can go console log, which will capture the value and then print it to the screen. That's another way you can capture values without having to define variables. Right? So 6 and 7. So it'll print those out as well. You can do that as well. The return values of functions can be treated just like a variable. So we'll say 1, a bunch of 1s, and then 2 and 5. And JavaScript has no problems taking the result of that function as a variable and adding it to the string to the left, right? So you get this nicely printed result. So that's another way you can do it. You don't have to define variables. You can return, if functions return something, you can treat that block of code as a variable as well. Even though this is nice and, shorter lines of code, it's just better to make them variables because you have a chance and heck of debugging that. And what I'm talking about is if you go here, you say, what if something doesn't work? Well, okay, you're on this line of code, but then you go inside the function. I just want to know what the variable was before I printed it. I don't want to go in the print statement and debug. It's just, it gets really nasty as your code grows, okay? So you should always do variables unless you're doing something funky. And this is where chaining gets nasty, but we'll get to that. All right, so let's talk about functions calling functions. So we have add two numbers, okay? What if we want to square two numbers? Now, if you don't know about what squaring is and exponents and you haven't gotten that into your math class yet, don't worry about it. You just take multiple numbers and add them to each other a bunch of times. That's all that exponents are. So we're going to do square. first, second. We're going to return the square root of the first and second numbers, okay? Now we could use math square root, but there are a variety of ways that you can override functions. Maybe you want to do a faster algorithm than JavaScript native provides, or maybe you want to put some checking. It doesn't matter. The point is we're going to do that, okay? Then, so we've got a square function. Now we're going to do our distance function. Distance, if you don't know what distance is, distance takes the distance between point A and point B and calculates it for you, okay? The way you do that in a two-dimensional plane just means X and Y coordinates like a map. There's no 3D. It's just, I'm here and I'm here, okay? So we're going to say point X1, X2, I'm sorry, Y1, and then an X location of 2 and a Y location of 2, okay? We're going to calculate the distance of that. So let's first get the distance. We'll say X2 minus X1, okay, the delta 1. How far is X1 from X2, right? If you minus X2 from X1, regardless of whether they're negative or not, you're going to get that delta. How far are they, the X's from each other, okay? Right, X, X, and then Y's, X, Y's, you got it? Longitude, latitude. Delta 2 is the Y's. So Y2 minus Y1. How far are they from each other, right? We need to know how far they are. Once you got those two deltas, or differences in value, delta is just a common word for programming for difference, right? Once you got the differences of those two, minus difference, right? Then you can square root them, which is the core of the distance formula. So we'll say, and notice I'm using bars, right? I don't want these variables to be polluted and global. I can make whatever variable names I want and not have to worry about affecting anybody else. So distance is the square root, or square, of delta 1, square 1, plus the square of delta 2. Now that we're done, we can return the distance formula. So, if we have two coordinates, we have a chord 1, which is what? An X of, I don't know, 30, and a Y of 30. And then we have another coordinate. The X is 100, and the Y is 100. How far are they from each other? Take into account the fact that they're both, randomly. Let's make it even more difficult to do in your head. So it's not 70 to 30 something. Yeah, there you go. I know some of you math whizzes out there are going to get this, but for people like me who don't, I'm like, help me programming. So what is the true distance? Notice I can use distance. Why? Because the function uses local variables. So what is the true distance of that? We're going to call our distance formula. Now notice he's calling the square function here. That's the key. We have functions calling functions. They're going to reuse algorithms. So the distance is chord 1. Let's name it chord 1 so we know the difference. Chord 1, X. Chord 1, Y. Chord 2, X. Chord 2, Y. What's the distance between those two? Console.log. It's 22, whatever they are, pixels, whatever else, right? It gives us a nice big old float. It's a decimal. But we could say, like, can you just round that home slice? That'd be great. Notice I'm doing a function that has a return value, round, math.round, but I'm not capturing it. I'm allowing the console to handle that and make it a variable. There we go. So much readable. Who needs silly decimals when you're calculating distance? It's not like we're doing military stuff here. Cool. So now we have a function calling a function. Now we could just as easily put that here, right? But who wants to do that? It's like more readable if you sequester a lot of these values down to have functions calling functions. Okay? So that is functions calling functions from a small place. Let's do some string. We'll play with some strings. Now we'll get into advanced strings and advanced numbers later, but let's do some string parsing. So strings have this awesome method called split. It's a really easy way to get an array of certain characters. So for example, if you have a sentence and we want to get all those words in a particular array, you can do that. This is really helpful for names. So if somebody gives you a list of names in a format, you can split on the comma and space, right? Because each one of those strings are characters that you can actually get at with programming. Strings have a really powerful API for accessing them. So we're going to say split strings. Maybe later on you decide that using an array is not the best methodology. Maybe the format could be different. You have to check. For now, we're just going to assume that everyone's given us a last name, comma, space first name, okay? And the parameter is name chunk. Chunk is another way of saying string, or chunk of characters, okay? String characters. You can call it whatever you want. That's what I call it. Doesn't matter. Whatever you do it consistently, right? Remember this stuff. I'm not just making it up. Maybe I. All right, so list of cars. So we're going to assume that our names look like this. I'm going to put a comment just so you can see in your head. We're going to have something that looks like this. Ward and Jesse, okay? It's going to be in quotes. We want to get this out and we want to get this out. The way we can do that is we can do some surgery on the string. So we're going to go name chunk, split, and do it on the comma space, just so you can see it actually work before we're completed. I'll log it out so you can see it in action. We'll say split strings on Warden Jesse. Okay? So we get an array, and it gives us all the strings that are divided on those particular items. Warden Jesse, right? You can see it's right there. Okay? So it's an array with 2 items. How do we access array items? 0 and 1 in this case. And that is last name and first name. You got it? So now that we have our names, now let's create a person. Create person from some random string. So let's say you want to serialize your data and save it in a text file. Maybe you're creating a game. Maybe you're reading from a database that was all string-based. We'll say big old string. The string, in this case, will look like this. Okay? So, first, let's get our first name, our person here. All right, so let's finish this one and say return an object with a first name, which is list of cars, 1, last name, list of cars, 0. Cool, so now we have a person object. Person. Split string. So let split strings handle getting the names of this big old string. Now we'll get our age, because we are caring about age. We got to find an age or a number in there, okay? So we'll do the same algorithm, right, on this, but we care about position 3. Now here is something special about numbers. They're not always going to come out as numbers. Sometimes they can, but in this case they're not. So we're going to say age string to be specific about what data type it is, right? List of cars 3. Then we're going to do a magic little function here called parse int. We'll call it age. It's age strings. So take a string. Hey, that string, it looks like a number. Can you make it a number in JavaScript? That'd be great if you could. Cool, thanks. Now we'll go person.age equals the age that we just created, and it's local as well, right? Return person. All right, so let's see that work. So now I have a string that looks like this. Split strings handles getting the name. This creates the person and gets the age. So it does double duty, but it tries to offload some of that parsing to here, okay? To make it a little bit more readable, a little bit more flexible. Because maybe the name will change. Maybe they'll put first name and last name. Who knows? So let's test it out and see if it works. Create person from random string. Let's get rid of these slashes here. All right, so we put a string in there. We know that it's going to get us a person. Let's just log it out and see what it gives us. Before we do that, let's fix that because it's not really name chunk, it's a big old string. There we go. Okay. There we go. We now have our person object, which has a first name, a last name, and an age. We can put all kinds of strings in here. Let's put Her Majesty. She's actually 23 as far as you're concerned. Put Toby 1. And there we go. We now have a function to parse objects out of these strings, right? We could actually make it go do the reverse. The point here is that we're using local variables, return values, with functions, again, calling functions, okay? So you can see how we can offload some of the work. We could also, and this is what's called refactoring, we can also do age as well. Parse age out of string. Name chunk. Notice this name chunk is different than this, right? It's in the function and acts like a global variable. Parameters do that. So we'll take the age string algorithm, cut it out of the other one, right? It's not big old string, it's a name chunk. It's going to get those list of characters, get the last one, then return the age. And then we'll say, instead of person.age, we'll just say person.parse age out of big old string. Perfect. Now this create person is a lot more readable. It uses two functions to handle the dirty work of parsing. It's just concerned about doing one thing, and that is creating the person, right? It doesn't actually have to deal with parsing them. Same function, same thing, same result. Pretty cool, right? So that's functions creating functions. And as you can see, this is going to grow. Maybe you want to do things with that person. Maybe you want to create game characters and draw them to the screen. We're going to create more functions to call more functions, right? To do that kind of stuff. So that's how that particular works. All right, so that's the basics of functions, okay? We've covered name functions, anonymous functions, function parameters. We've covered dealing with arguments that you actually are named arguments, or dynamic using the arguments array, right? Which is a magic array that all arrays get. It's also called REST-based programming, where REST-based function calls, where you put an arbitrary amount of functions with no names. We've talked briefly about local variables and how the scope of putting a var here hides it from global. It's different from the global scope. So you have all variables you define up here are on global, whereas if you var inside of functions, it only exists inside the function. It uses that variable if you access it by name, not the global one. If you want to access the global, you have to go window.global, right? We've also talked about return values, where functions can return values from the function, and as long as you have a variable, you can catch it. The return also stops code execution, so anything below it will not run. And you can also put return with nothing. It'll return null or undefined. And to show you, let's show you what the result is, right? Right, undefined, because you didn't return null, you return nothing. And finally, we've covered the functions calling functions. So you can have functions that call other functions, which forms the basics of how programs are built. Functions calling functions, right? Regardless of where they're defined or named. So we'll get into chaining functions and call and apply and promises and dynamically calling functions later on when we cover OOP and classes and things like that. But once you understand these basics of functions, you've got majority of programming. You've already got variables, you've already got loops, you've already got arrays dealing with the data types. Once you assemble functions together, that's the crux of programming. So it'll take you a few tries. Once you do it, you should definitely play around the console. You can define functions here as well and play there.